Hi everyone. So in this video I want to explain how dimensioning works. I'm going to be using three terms: datum, position dimension, and size dimension, and I'll explain the relationship between those two and how they work. So just to give you some idea of what we're going to do with this model, I'm going to collapse this item, and then I'm going to use under the evaluate tab the interference detection tool, and I'm going to calculate, and you will see it says no interferences. So we can just double check this by, I'm going to say okay to that. We don't need to double check it. I'm just saying visually we can see what's going on. So at the moment you see I've got a gap. Oh, I can see that one's larger than it should be. But I've given it a gap, a minimum gap of 0.25 millimeters, a very small gap. And that ensures that one part fits inside the other. So that's called a clearance fit. And if they interfered with one another, it would be called an interference fit. So let's first of all just go across to this empty. It should be empty, but it isn't. So I'm going to this empty file, and I'm going to show you something about the origin, why the origin is in fact your datum just about all the time if you fully define the sketches. If I select that datum, you can see it puts a point in there. So let's put a sketch in on the front plane. And I'm not going to sketch, I'm just going to select my origin. Now the origin's got two arms. It's got a larger red arm pointing upwards and a smaller one pointing to the right. But and so that's just giving you the y-axis and the x-axis. If I click on the datum and then click on the side view of the top plane, you'll see that they connect. That datum is on this plane and represents that little small red arrow. If I do the same for the right plane, in fact, let's just go back to our normal two and do that. So that point also coincides with the right plane, and then the red arrow points upwards to coincide with it. So the way to think about datums is that they're actually planes. You will always need two datum planes, even though in normal language you're going to be talking about datum features or datum and the datum point. So the point represents two features, two datum features. Now, when it gets a bit more complicated, you'll be able to understand that datum features needn't be planes. They could be cylinders. They could be anything you want, in fact. But the basic idea is that you start from the idea that they are planes. So let's sketch on here, and I'll show you why datums and position dimensions are so important. So I'm just going to round this item off. So let's assume this were some sort of piece of wood that you wanted to put some holes into, and that you modeled this up in your Solidworks program, and you now wanted to tell either yourself or someone else that you want a hole of 20 millimeters and where do you want to put it. So at the moment, because I've chosen to put this block of wood centrally, it has center lines. We would assume that you would draw center lines on your block of wood, and we're going to use the center lines as our datums corresponding with the y and the x-axis. So the first position dimension, and you're always going to want two position dimensions. Well, mostly are going to want two position dimensions, but we can see what happens the moment we put the two in. Solidworks has it as fully defined, right? So it's working on the same principles as you would be working on regarding datums. So it's fully defined once the origin allows you to position this item. So let's just do that with a rectangle. So what happens if we have an item which has more than one size position? Okay, so this has two sizes. I think that should be obvious, 30 by 44, whereas that only has one. It's a diameter, a circle of 20. So what I can do is I can either go from the datum to the one side, and then from the datum to another side, or I could go to that side, whichever one's more important to me. And now it's fully defined. So not only is it fully defined as far as SolidWorks is concerned, but if you were to go and make a drawing of this and you were to use these same dimensions, it would also be correct as far as having both both position dimensions in place. So you only need one set of position dimensions per feature, and then the size dimensions, but you might have more than one size dimension. What I can also do is, depending on what's important to me, on what my design intent, I could actually make these center lines the position dimensions. So what I'm doing here is I'm just grabbing that end and I'm locating it. So that could be important because maybe there's a reciprocal part on another block of wood that comes out that has to fit inside here. So I can limit the areas that I'm going to make by making those center lines. You'll see how that works in a moment. By making those center lines the size positions. All right, so just one more thing, maybe. Just have a look at this rectangle, the main rectangle. You might say, well, okay, it's fully defined. What position does it have? Well, it has a position of being 0, 0. So it starts from 0, and we know that each one of these lines is centered on either the verticals or the horizontals. So we know that this is positioned around the 0, 0 at a distance of 140 to either side, left to right, and of 80 top to bottom. So many size positions are implied, and you'll get to understand that better as we go along. I mean, I could do one more thing. We could put a circle in here of 20 as well. So that should be a diameter of 40. What is that? Doesn't really matter. Yes, diameter 40. So you might say, where's that circle's position? Once again, it's 0, 0 because it's on the 0 point. Okay, so back to, well, we could go back to this one. I'm going to go to the shaft because that shaft is part of my assembly. And I've got the dimensions showing here because I've mark them as an annotation. I'm going to edit the sketch. And at the top here, I've got a driven dimension, which means that, well, you'll see it change. It means that I can't use it to change anything. If I click in here, it'll tell me, you're not allowed to. All right. But these here are arranged in what's called a chain dimension arrangement. Not really a good way of arranging dimensions, but I want to show you why the datum is so important, because the datum is the place that you should start all your dimensions instead of, as I've got it here, 100 and then from the end of 127 and from the end of 27, etc. So I just want you to see at the top here, I've given this a manufacturing tolerance of 0.5 millimeters plus or minus. What that means is that if I were to make this, I need to give myself or whoever's going to make this some sort of allowance for error. Now, whether it's because of the machine you're using or because of your own skills, there's always going to have to be some kind of allowance. And in this case, that's a pretty large allowance. That means that could be 100.5 or 95.5. And each one of these could grow bigger or smaller by 0.5 millimeter. I'm doing this just to illustrate, so we're going to reduce that a little bit later. So let's just add, as if we were manufacturing, let's add the maximum in each case. Theoretically, that could happen. I mean, very unlikely, but it could happen. So let's just do that. And I'm just going to copy the 0.5 so that I don't have to enter it each time. Control copy. Okay, watch what happens at the top here. This dimension is going to grow. So each time I add a 0.5 in there, see it's now up to 216.5, 217. Okay, and if I exit this and we go back to this item here and let's just collapse it and do another interference detection and calculate, you'll see that there are now 3 rather large interferences between this part, so I will not be able to fit it together. Let's revisit this one and go back to the sketch. Now, I've entered my original dimensions in here just to remind me what they were, because otherwise the calculations become a bit difficult. And I'm going to change this, this manufacturing tolerance to be a bit more realistic, 0.25. So that means I can get larger by 0.25 and smaller by 0.25. And then I'm going to delete, let's delete all of those. And we still want, so this one should go back to 100. And this time, instead of dimensioning in a chain dimension way, I'm going to use the right way, which is to always go back to the datum. So I've got my dimensions in the top there so that I don't type the wrong ones in, so that we're replicating the same as the original, and not introducing changes. So this would be the same as where I started in the beginning, except I'm using a different way of dimensioning. And that should be 215. Okay, so now this 215 would be the same as that driven dimension that I had in the beginning. Watch how it grows now, because I'm going to apply that tolerance also in the maximum fashion to each one of these. So I'm going to type in 0.25. Once again, I'm just going to copy that to save time. And now I'm limiting how much the error growth may be over the total item as I do this. See, the top one has not grown at all. It's stayed the same. Okay. So it's still at 215. Only if I added this in here would it increase. So I've limited the total possible growth of this part by 0.25 millimeters, which is my clearance as well. And I've also limited it in the opposite direction. So if I were to take this as minus for each one of these, the minimum amount I would have is 214.75. Let's exit this and go back to this item here. And I'll just update just to make sure that we don't get a false reading here. And I'm going to go back to evaluate and do an interference detection, and I should get no interference. So there's no interference, okay? And we can just see what's happening in the actual part. You can see that what's happened is that the far faces of each of these rings, or of the shaft and these outer rings, matches the face over here, not at the bottom. It matches it, but it doesn't interfere. So no matter what I do, I can make sure that the one part fits into the other. And I've done that by simply using the datums. So this is why datums are so important. This is why all your dimensioning must start from datums. Right, I think that covers it for this video. I'm going to do another video on how to dimension in a drawing, which will use the same block. Thanks for watching.